This question says, solve the following exponential equation, express irrational solutions in exact form, and as a decimal rounded to 3 decimal places. This equation is 6 to the 2x plus 6 to the x minus 12 equals 0. In this exponential equation, it follows a special pattern, and we're going to use a special method to solve this equation. What we're going to do is, well, what we should notice first is the special pattern. So the special pattern is that this kind of follows a quadratic format where we have 3 terms. Let me remind you, quadratic format. It's ax squared plus bx plus c equals 0. So quadratic equation would follow this form. And so the similarities to this format is that you notice we have our 3 terms, 6 to the 2x, 6 to the x, and the minus 12. So the minus 12 is like the constant. And then for the exponents, what we notice is that we have for the quadratic a 2 and a 1 for the powers. And what we have here is a 2x and an x for our powers. So because it follows that pattern of having the 3 terms, one of them being a constant, and also having one power be double the other power, we can use this special method, which is called U substitution. So with U substitution, we're going to let U be equal to the 6x that we see in the middle. And then if we were to square the left-hand side, so U is on the left, we're squaring the left, and I'm also going to square the right. What that gives me is 6 to the 2x. We get that by using the power rule for exponents. The power rule for exponents is when you have a power to a power, you multiply those powers together. So with this substitution, we're going to change our equation, which had those similar properties to a quadratic, and watch what happens when we make that substitution. So the 6 to the 2x becomes u squared. The 6 to the x becomes u. We carry down the minus 12, and that transformation that happened when we did the substitution turned the equation into a quadratic. So remember I said it started out similar to a quadratic, and when we did that substitution it actually turned it into a quadratic. Now this is nice because once you have a quadratic equation, you're able to use all of the methods for solving quadratic equations. This one is going to work out nicely by just factoring, but if you prefer, you could use the quadratic formula. So this factors into u and u. 4 and 3, we're going to have a positive on the 4 and a negative on the 3. And we'll set each factor equal to 0 and solve. So we can subtract 4 on both sides to get u equals negative 4. Add 3 on both sides to get u equals 3. Now we've solved this intermediate equation for u, but what we really wanted to know is what is x. So now we're going to bring back the substitution that we made so that we can bring back the x. So u was 6 to the x, so we're going to put this u to be 6 to the x, and this u to be 6 to the x, and solve these exponential equations that we have left. Now the exponential equation 6 to the x equals negative 4 is something that doesn't make sense, because you have a positive value raised to a power equal to a negative value, and that can't happen. So we're not going to get any solutions from that equation there. But the other one we can solve by either taking the log of both sides or converting it to a logarithm. I'll take the log of both sides. If I take the log on the left, I have natural log of 6 to the x, and on the right, I'll have natural log 3. Then I can use the power rule to get that variable out of the exponent, and then I can get, I wrote 6 instead of 3. So then I can get that variable by itself by dividing by natural log of 6 on both sides, and that gives me my solution of x equals natural log 3 over natural log 6. Thank you for checking out my videos. Have a great day.